Hello. Today I am going to be talking to you a little bit about measuring and converting matter in chemistry. Anytime we do any kinds of labs and in many of our calculations, you are going to need to be familiar with the units that we are going to use in chemistry, specifically the metric system, and how to convert between those units, like grams to milligrams, or probably more commonly kilograms to grams and milliliters to liters. So we'll be going over all of that today, and then you'll have a chance to practice converting on your own. So you are going to be taking notes along with me today. So if you don't have your stuff out for taking notes, please go ahead and get out some paper and something to write with. You can pause this video. But we're going to go ahead and title our notes Chemistry, because I want to begin by reviewing exactly what chemistry is. And as you remember from our first day of class, well, actually, I believe we talked about it on our second day, we said that chemistry is the study of matter and energy. Remember that energy will be a separate unit that we'll study in second semester. I want to focus on this word matter. And we said on that second day of class that matter is anything that is made up of atoms, right? So I'm just going to, underneath the word matter, add the word atoms, but I have another definition of matter that I'd like us to consider for a moment. And I think that it makes it even easier to identify things as being matter or not. Matter is really anything with mass and volume. Anything with mass, and it has to have both volume. So this might be an even easier way to identify whether or not something is matter. Does the object have mass? Does the object have volume? And we're going to define what mass and volume are today in our conversation. Before we get into that, though, what I want to do is just get some examples of matter and not matter down on our paper. Okay, so go ahead and put your pencil down for a second and bear with me. We're going to flip over to a different screen here. I'm going to give you a list of items. Okay, and I want you to identify them as being matter or not matter. So you can make a little T table in your notes, title one side matter and one side not matter. And I want you to pause the video and take a moment to put the words into whichever category they belong in, whether they're matter or not matter. Okay, so now that you've done that, we're going to go ahead and go over the correct answers. Let's see how you did. How's your T table look? Is this what you came up with? From that list, the items that are matter are bacteria, batteries, clouds, DNA, dust, and sun. All of those items, even when you consider them on the individual one particle example, all of those items are made up of matter, made up of atoms. In other words, all of them have mass and volume. Okay, now sometimes their mass and volume might be insanely small, but they definitely have mass and volume. Things like fear or other emotions, sound, sunlight, wind are not matter. In some of those cases, especially the case of sound and sunlight and wind, it's the result of energy or movement, but it's not actually matter itself. So for example, I can't capture wind in a jar, right? Or sound in a jar. It doesn't take up space and it doesn't have mass. I can't take my fear and set it onto a balance to see how much mass it has. Okay? So go ahead and jot that down in your notes for me real quick. That T table. And again, you can pause here if you need to get caught up so that you have enough examples of each. And I'm going to cheat. I have a little list here. I'm just going to add. These are my examples of matter and not matter. Okay? Now, we're going to move on from our discussion of what's matter and what's not matter and talk about chemistry and how we handle that matter. How we truly, what we're really looking at is how do we observe this matter, okay? And the first thing I need you to understand is that making observations is an important part of any science, right? Like whether you're in earth science and observing rocks, or biology and observing animals or plants, or physics and observing car crashes, observations are an incredibly important part of science. So making observations is an important part of science. And it's true for any particular science. Now, there are basically two types or two kinds of observations. The first kind that I want you to be familiar with are qualitative observations. And qualitative observations are basically observations that are descriptions. So you make them with words. So the solution is cold, the solution is blue, the solution is clear, or the solution is foggy. Those are all descriptions with words. The other type of observation, and it's the one that we're going to focus on today, are quantitative observations. And as the term quantitative suggests, we see the word quantity in there. So we know that quantitative observations involve numbers and units. And the units is really important. If we leave the units off of our observations, they don't really tell us anything. They're just random numbers on a piece of paper. So quantitative observation involves numbers and units. And like I said, this is the type of observation that we're going to focus on right now when we discuss measuring in chemistry. Okay, so quantitative involve numbers and units. One of the great parts about a video recorded lecture, obviously, is that you can pause and catch up if I am going too fast for you if you need to write your notes down. Okay, so now we're going to talk about measuring in chemistry. And there's a couple of points I want to make with regards to measuring chemistry, especially in my class, right? Because if you had a different chemistry teacher, you might get a little bit of a different information here, or maybe when you take this class in college, you'll get a little bit of different information. But the first thing I need you to remember about measuring in chemistry, so anytime we're dealing with quantitative observations of a sample, is that we are going to have no naked numbers. And what I mean by that is that you are going to always include units. So including the unit is always worth at least 1 point on problems. So like, remember we talked a little bit about how we're going to learn how to do stoichiometry. Stoichiometry problems are usually 5 points, where one of those points, so 20% of the score, comes from having the correct unit. So you always need to include the unit. Now, the other rule or standard that I want to use when we're doing measuring in chemistry in this class is that we are going to round to 2 decimals. Now, when you take chemistry in college, you're going to have to be concerned about something called significant figures. We're not really going to spend any time on that right now, just adds an extra wrench in there that we don't need to worry about. But significant figures is the idea that we don't have more numbers in our answer than we were given to work with. So just a way to make sure that you're not estimating too far. So in our class, we're not going to deal with any of that. We're just going to all say that, you know what, we're going to round to 2 decimals, and that should hopefully get our answers a lot closer together. There will still be lots of variation in our answers, and that's why showing your work and stuff is very important when we do chemistry, and I'll refer to that more when we get closer to needing to do that, because there can be some difference in rounding. But if we just all say, you know what, we're going to round to 2 decimals from the beginning, if we all follow that pattern, we'll get really close on our answers. Okay. So what do I mean by that? Well, for example, if I was to ask you to take 5 divided by 3 and you were to type it into your calculator, what you would get is a number that probably looks something like this. And the number of 6s there is 100% dependent on how many digits can fit in your calculator. But this actually goes on and on and on and on for a really long time. I don't want anybody to write out that many numbers. We all have other things to do. So when you take 5 divided by 3 in your calculator and go to write down an answer on your paper, you're going to round to 2 decimals, right? So you look at the second decimal place. This number, of course, is greater than 5. Oh, I'm sorry. You look at this decimal place. This number is greater than 5. So we round up. So we're going to round the next number up. Okay, so according to our calculations in this class, we wouldn't use this number. We would use 1.67. Okay, so that's what I mean when I ask you to round to 2 decimals. Okay, so those are the 2 rules that I want you to keep track of when you are measuring and doing calculations in chemistry. Also, when we get to the mole, there are going to be some specific requirements for how you show your work. I'm not going to worry about that with the metric system conversions, but just have that in the back of your mind that you are going to need to be keeping track of work and showing exactly how you came up with an answer. Okay? So I want to go back to our original definition of chemistry just really quick here, where we said that chemistry is a study of matter, and matter is anything with mass and volume. So what I'd like to do next is take a moment and discuss exactly what mass is with you. Okay? So what is mass? Okay, and by definition, mass is how much matter or how many atoms are present. So how much matter there is in your sample. The reason this can be true goes back to that idea of the mole that I told you about earlier. We know that there is an equivalent amount of atoms to mass. And again, this doesn't mean anything to you yet, but once you eventually learn that, you would be able to take a mass of a substance and convert it to exactly how many particles, atoms, or molecules there are in the sample. Okay? So how do we measure mass in the lab? What's our tool that we use to measure mass? Anybody know? It's known as the balance, or sometimes people call it a scale, okay? So the tool used to measure mass in chemistry is the balance, and the unit, or the base unit to be exact, is the gram. Now, real quick, just to make sure we're all on the same page, I do have a picture of a balance for you. Let's put this up on here. I'm going to jump through this. Okay, so this is an example of an electronic balance, and we have several that look like this or very similar to this. You put your object onto the scale, and then you get the mass in grams. Of course, you would never put your object directly on the scale, right? We'd always put a piece of paper down to protect it, but you get the idea. Okay, now the base unit for working with mass, as I mentioned, is the gram. And one cool thing about the metric system is they have a way of making the gram bigger or smaller based on what you're going to be using it for measuring. So if you're going to be measuring something very, very, very small, then you would use the prefix milligram to describe the object. So, for example, a sample, or this is like a dose of Advil that the normal person is supposed to take, has 200 milligrams of ibuprofen. Okay, and here's an example of a mosquito, which weighs 2.5 milligrams. So you can see that they're even tinier than a gram. And of course, a paperclip weighs about a gram, so we just use the 1 gram index. If we are measuring something very large, then we would use the prefix kilo. Okay, so for example, this is a huge football player. Okay, this huge football player here has a mass of about 181.44 kilograms, which is like 360-ish pounds. It's a big dude, okay? Or a bus would be about 10,000 kilograms. So when you're wanting to talk about something that is really, really huge, then you're going to use the gram, okay? So back to our notes here. Let's put that information down. So when we are talking about small things, you're going to use the prefix milli. In case you didn't know that, the prefix milli refers to 1/1000th. Now, if you're talking about large things, then you're going to use the prefix kilo. Now, one of the many things that I love about the metric system is that we can take these prefixes and we can apply them to other base units. So the gram is for mass, but if we were talking about volume, then you could use like a milliliter. That's the base unit for a liter, which we'll talk about momentarily, okay? A kilo refers to 1,000, okay? Now, I do expect you to already know conversion facts about matter and about grams, but just in case you have forgotten, we're going to write a couple down on our paper right now. For example, you should already know that 1 gram is equal to 1,000 milligrams. This is something that you should know, right? And if you don't know, it's something that I expect you to know how to look up and find if you need it. Same thing for a kilogram. 1 kilogram is equal to 1,000 grams. So those are prefixes that you conversion facts that you should absolutely know. So maybe that would be worth highlighting or doing something to mark them, but I expect you to know that. Anytime we're working in a lab, you should know those conversion facts. And more importantly, you should be able to use those conversion facts to change units. For example, I might give you grams and you have to convert to kilograms for a calculation, or I might give you milligrams and you need to know how many grams that is. Okay, so I want to discuss that really quick. How do we do these conversions if you don't know? Some of you can just do it in your head. It's as simple as a multiply or a divide by 1,000. But for those of you who it's been a while and you haven't thought about it lately, I want to review with you really quick how you go about doing that, okay? And in order to discuss that, we need to remember something about conversion facts, okay? So 1 gram is equal to 1,000 milligrams is our conversion fact. Here, I want to be able to see this still while we're writing. Sorry, this is getting all kinds of crooked, okay? Is our conversion fact. We can write conversion facts as fractions so that we can use them mathematically to solve a problem. So 1 kilogram is equal to 1,000 milligrams can be written either as a fraction with 1 gram on the top and 1,000 milligrams on the bottom, or you can flip it over and you can put 1,000 milligrams on the top and 1 gram on the bottom. And the reason it's important to understand that you can write a conversion fact as a fraction is because the fraction is how we're going to change from one unit to the next. And I'll show you what I mean, okay? So for example, let's say that I have 0.85 grams, and I want you to convert that to milligrams. Well, to do that, you can either do it in your head because you're familiar with conversion facts, or you can remember that when you multiply by a fraction, you can get rid of units, right? So if I have 0.85 grams and I want to get rid of this value in my problem, where would I want to have it in my fraction to get rid of it? I'd want it to go where it would cancel, right? So if grams is on the top here, then I would want grams on the bottom to cancel. And I know from up here that I can write this conversion fact as this fraction. So I can put 1 gram on the bottom and 1,000 milligrams, oops, I forgot a 0, on the top. And the words cancel, and I'm left with just numbers and a final unit. So to solve this, I just have to multiply by what's on the top and divide by what's on the bottom. Okay, so I'll do 0.85 times 1,000, which would give me 850 milligrams. Now again, many of you are sitting here going, I can do that in my head. Great, please do. I'm not going to force you to show your work on these types of calculations. This idea of multiplying by a fraction to change a unit, though, is going to come back when we do the mole, and I'll reemphasize that then, okay? What if I need to go the other way in this problem, all right? For example, what if I want you to do, I don't know, let's do 450 milligrams, 2 grams. How's it work this time? Well, again, we take our given and we then identify the fraction that we're going to need to use or to multiply by in order to get rid of the milligram. So if I look back up here on my fraction, I need to have milligram on the bottom to get rid of it, so I can write my conversion fact as a fraction here. And then I can plug that into my equation, where I put 1 gram over 1,000 milligrams. And if I put the 1,000 milligrams on the bottom, then those words cancel, and I just need to do the math. Now again, how do we handle a fraction? Well, we multiply by whatever's on the top and we divide by whatever's on the bottom. So 450 times 1 divided by 1,000. So that's equal to 0.45 grams. Okay? So again, you don't have to show your math here, but you need to understand how you're getting those numbers. So if you can do this in your head and you're good to go, great. If you're like, I'm so confused, I don't know whether I should multiply or divide by 1,000, then that's when I want you to use this format to show this work so that you can kind of see your thinking, okay? If you ever ask for help, this is how I'll help you, is I'll have you consider those fractions, all right? So let's go back and talk about the kilogram right now. So if it was true, sorry, I'm adjusting to this whole, that did not help. If it was true that 1 kilogram equals 1,000 milligrams and we can write it as these two fractions, the same thing goes for over here, right? We can write this conversion fact as two different fractions where 1 kilogram can go on top and 1,000 grams can go on the bottom. Or we could put the 1,000 grams on the top and the 1 kilogram on the bottom. What I really want you to see is that in both cases, I'm not changing the numbers or flipping the units, right? I'm taking the same value and setting it equal to the same other value. It's just how I write it. And I'd write it that particular way based on what I was trying to do in my problem. So for example, let's say that I want to change 789 kilograms to grams. What would that look like? So I'm going to take 789 kilograms and I'm going to multiply it by a fraction that allows me to get rid of the word kilogram and have the word gram. So if I want to get rid of kilograms, then I need to put kilograms on the bottom. And since this fraction has kilograms on the bottom, this is the fraction that I'm going to use. 1 kilogram on the bottom, 1,000 grams on the top. So then I would just take 789 kilograms and times it by 1,000, and I would get my answer, and it's a big one, 789,000 grams. Okay? So it's all about picking the proper conversion fact. Again, some of you are really good at this already or had a different way of memorizing how you convert units. So you can easily switch from one to the other by multiplying or dividing by 1,000. And if you know exactly what you need to do that and can do it in your head, awesome. Go for it. You don't need to worry about showing your work. But if you're a little bit confused, then what I would love to see on your paper are these fractions set up in this format so that you're checking, so that you know that, oh, okay, this number needs to go on top, so this number goes on the bottom, and then how do I solve that mathematically? And of course, remembering that when you multiply by a fraction, you're always going to multiply by the number that's on the top and divide by the number that's on the bottom. Okay? So that's our review for mass. And again, mass is anything that has substance, right? So anything that's made up of matter is what is mass. What I want to talk about next then is volume. Okay, and exactly what volume is. So matter is anything that has mass and volume. So we're going over what mass and volume are right now. So if mass is how much matter there is, then volume is how much space the matter occupies. So how much space the atoms occupy. What are they taking up? Okay, so how do we measure volume? Okay, well, there's a couple of ways. And honestly, it depends on what we're trying to measure. Okay, so if we are talking about liquids or irregular objects, then the tool that you're going to use is something called a graduated cylinder. So for a liquid, you just straight up pour the liquid into the graduated cylinder and you can measure the volume. For the irregularly shaped object, you're going to use a graduated cylinder and you're going to do something called water displacement. You guys have all seen this before. In water displacement, what you're going to do is take your graduated cylinder and put some water in it, note the mark. Then drop your item into the water in the graduated cylinder and notice how it changes. That difference between the pure liquid and then the liquid with whatever the object is the volume of that object. Okay. Now, if we're talking about a regularly shaped solid, so a regular shaped solid, so like a square or a rectangle, right? Then you can simply take length times width times your depth, and that will give you your volume. You guys have all heard of that before, okay? And just like mass, there are base units for volume. The base units for volume, or the base unit, I guess I should say, for volume, it's exciting, is the liter. So we measure volume in liters. So it's really important that you know that whenever I ask you to find the mass of something, you know that you're getting the grams and you're getting that using a scale. And so the unit that you would put on the number is a G. And if I ask you to get the volume of something, then you would go ahead and get a graduated cylinder out, and the unit that you would use would be the liter, or a capital L. Okay. Now, just like, I'm going to minimize this for a moment, with grams, we had a way to look at large grams and small grams. The same is true for volume. So again, the equipment that's used is a graduated cylinder. The unit is the liter. And here are some examples of things that we measure in liters. Interesting enough, we don't ever really use a kiloliter, so you won't find any KLs. So like here's a 2-liter bottle of pop, or this hot air balloon holds 500,000 liters of gas. Okay. If we're talking about something very small, then we would use the milli prefix, which would talk about 1,000th of a liter, right? 1/1000th of a liter. So for example, like little babies take 1.5 milliliters of medicine. Your water bottle carries about 750 milliliters of water, like your average can of soda has about 355 milliliters, right? So a little less than half of an overall liter, okay? So back to our notes here. When we are measuring small volumes, you guys are going to want to use milli. And for whatever reason, they don't use kilo as a preference or as a prefix for liters. I'm not sure why, but they just don't. So we would be talking about small volumes. We would call those milliliters. Really common in chemistry. And in chemistry, it's also really common for you to need to be able to switch from liters to milliliters or milliliters to liters in order to do a conversion. So you need to absolutely know that 1 liter is equal to 1,000 milliliters. So this is a conversion fact that you should have memorized. Again, notice that the numbers involved are always a nice even 1,000. So really all you need to remember is whether or not a milliliter is bigger or smaller than a liter. And if you know that, then you know that it's 1,000 times smaller, okay? Now, just like with grams, we can write liters or milliliters as a fraction. We can take this conversion fact and write it as a fraction so that we can solve problems. So we know that 1 liter can be over 1,000 milliliters in whatever setting we need that. Or we also know that we could write this conversion fact as a fraction that says that 1,000 milliliters over 1 liter is true. So now when we're asked to do a couple of examples, right, to switch from one to the other, it's very easy. We just have to remember which version of that conversion fact we want to work with. So for example, let's say that I want you to take, let's see here, 0.54 liters and convert it to milliliters. What's that going to look like? Well, I'll take my 0.54 liters and I'm going to multiply it by a fraction so that I can get rid of this word liter and turn it into the word milliliter. So if I have liter on top, where do I want it in my fraction? I want it in the bottom. Very good. So this is the version of that we would want to use. So we'll put 1 liter on the bottom and 1,000 milliliters on the top. And that word liter will cancel. And so to go from 0.54 liters to milliliters, you just multiply by 1,000. So 0.54 times 1,000. Now, again, as I mentioned earlier, this is the correct format for the work. I do not actually care if you show the work when we're doing these metric conversions. Many of you can just do this in your head. Great. Make sure when you go to write your answer down that you include your unit though. Okay, just don't write down the number, but include your answer. All right, let's look at one more example, and then I'm going to release you to go answer some practice problems on your own. What if I said that I have 2,750 milliliters, and I want to know how many liters that is? How would I solve this problem? So again, we take our given, and we're going to multiply it by this conversion fact written as a fraction. And if we have milliliters on top, where do we want it to go to get rid of it? On the bottom. Very well. So we look at one of these two fractions. Both are saying the exact same thing, which is this. Which one has milliliters on the bottom? This one, right? So we write that fraction into our problem. And we can see that milliliters cancels, right? So I can go ahead and do the math. So I know that I can take 2,750 times 1 and then divide by 1,000. So I get 2.75 liters. Okay? So that's a quick review for you of how you do metric conversions. The units that I want you to be really familiar with that we're going to use most often are mass and volume. We'll also work a little bit with temperature, but we don't really worry about that until we are doing solutions and talking a little bit about gases in the mole. So you don't need to worry about that for now. Okay. So it's now your turn to go and practice. You have some practice problems to take what you learned just now and convert it into some thoughts and apply it. And so go ahead and get started. As always, please let me know if you have any questions. Thanks.